Here we're letting f of x equal 1 half x plus 1, and we want to find the limit as x approaches 3. Also, we want to prove that that limit is true using an epsilon delta technique. So the first thing to notice is that the limit of the function can be found by direct substitution. So we plug in 3, we have 3 halves plus 1, or 5 halves. Now let's show that that actually is the limit. So we'll start out by letting epsilon be greater than 0 be given to us. Okay, we have to choose a delta value. We don't know that yet, but we'll get that value. If our x values are really close to 3, then this will imply that our height values, our function, our y values, are really close to the limit, which is, let's write this down as 5 halves. Let's give ourselves a little bit of space here to do our side work. So our function again is 1 half x plus 1. So the difference between that and the limits, is given by this. Now let's go ahead and play around with this. Remember, we want this guy to look like x minus 3 up here. So this is going to be 1 half x. Now let's get everything to have a common denominator here. So this would be plus 1 half minus 5 halves. So this is the absolute value of 1 half x minus 4 halves. So I've got, oops, that's not 1 half. Let's go back. There's going to be a problem there, right? So 1 is really 2 halves. So 2 halves minus 5 halves is 3 halves, just like that. If we continue, we can factor out a half on the inside here, and we're going to get x minus 3. That, by the way, is what we wanted up here. So this is going to be equal to the absolute value of a half times the absolute value of x minus 3, which is equal to 1 half times the absolute value of x minus 3. Now, let's go like this. X minus 3, the absolute value of it, is less than delta, which means that this expression has to be less than 1 half of delta. Now we want this guy to be equal to epsilon. So what epsilon do we choose? Well, some of you can just see what to choose. Okay. We want this guy to be equal to epsilon. So to make these two equal to each other, here's where this piece comes in. So delta, if 1 half delta has to be equal to epsilon, then delta has to be equal to twice epsilon. So this up here will replace with 2 epsilon. So now we can finish it. So then this is equal to this. Whoops, we got our x in there. Which is equal to this. And since this guy is less than epsilon, we get this is less than 1 half delta, and we know that a half of delta should be equal to just 1 epsilon. Therefore, we have f of x minus L is less than the epsilon that was chosen in the beginning. Thus, the limit as x approaches 3 of 1 half x plus 1 is equal to 5 halves. So again, this guy right here is your proof. It doesn't like to write well on the side. We'll write it below here. So this whole thing in yellow here, that's your proof.